Hello everybody and welcome to the Creatrix YouTube channel. I welcome you all in a fresh session of analog electronics. And my dear friends, when I say we are going to learn analog electronics from the very basic, I mean it. We will be learning from the very basic level to the very advanced level along with a lots and lots of questions. So before we do that, let me first introduce myself for my friend who is meeting me for the first time. My dear friends, my name is Ankit Goyal. I got AIR1 twice in GATE in 2014 and 2018. I was awarded the President of India Gold Medal in the year 2013 when I graduated from IIT Indore. Till date, I have trained more than 1 lakh students in the online and the offline classes and presently working as a director at Unacademy for GATE department. But my dear friends, the reason behind this series is because of the huge demand of analog electronics and the belief that whenever you ask for anything, we are there to deliver. Yes, my dear friends, we are here for you. We are here delivering for you. And when we say it, we'll support you to the very fullest level. And this series will help you crack GATE with the top rank. It will enable ECE student to get 12 out of 12 and 5 out of 5 for electrical students. So my dear friends, if you want to learn with us live, then you can join Unacademy using the code Ankit ESE to get an immediate 10% discount. And not only, my dear friend, 10% discount, it also brings you under my guidance so that I can help you do something that I have done. I can at least take you near to this goal. Okay. So if you also dream the same thing, then join me in this journey on Unacademy subscription using the code Ankit ESE. Now, my dear friend, if you like the content that I deliver, you can watch more of my free videos on this URL, tinyurl.com/AnkitESE. Here you will find all my videos arranged subject-wise, chapter-wise, and you will find great content for free. And you are definitely going to love it. You are definitely going to enjoy. It not only includes conceptual videos, but it also includes problem-solving sessions. So just visit this once and you will fall in love with this URL. Don't forget it. It is a lifeline for you. And if you love the content that we are delivering on YouTube, we have created the first ever video book for you guys, where you will find all the videos along with all the notes that we provide arranged subject wise, chapter wise. So now, my dear friends, your dreams are no longer dreams. They are becoming a reality because you are getting a top quality course, well arranged, well structured, and that too for free. So what can be better than that? What can be better than that? Nothing, my dear friends. So we have empowered the dreams of those who earlier used to think that only the person with a huge amount of money can crack GATE with a top rank. No, my dear friends, that is not the case. Even you can do. Even you can do it. But yes, just you need to believe in yourself and visit this link. But remember, this is a case sensitive link, so write this in uppercase. Other than that, if you join plus subscription, you get all the top educators like me teaching you live in daily lectures, along with providing you daily practice paper, weekly quiz, test series, previous year question, practice question, crash course, rank improvement batch, and most importantly, clearing your each and every doubt. So if you join plus subscription, it is an entire world inside it. So you don't have to look outside. Once you enter plus, every need of yours will be taken care of, and we will make your journey as smooth as possible towards that destination of getting under 100, under 10 rank. Believe me, my friend, you leave that strategy part to us. You leave the content part to us. You just work hard and we will make sure that you obtain the top rank in GATE and ESE. And Iconic is a big brother of Plus. Yes, this is a little brother. So Iconic gives you everything that a Plus subscription gives, along with much more. The major part of Iconic is this personal coach, a person dedicated to you on a daily basis to get you the top rank, guiding you, getting your schedule design, making your strategy. Everything that you need to get the top rank is being done by this personal coach. He'll also create a study planner for you, which you can follow blindly and reach your destination with utmost ease. They will be analyzing your test result and tell you where you are lacking, how you can improve. So that way, my dear friend, everybody else will get a standard analysis, but you will get an analysis just tailor-made for you. Along with it, we have included study material additionally, theory and question bank, and soon we'll be introducing interview guidance into this. So this will become a complete package for a student who wants to take that journey from being an average student to sitting into a PSU or a MTech seat. So for them, this journey will be just like driving a Lamborghini to work. So that sort of a experience, that sort of a royal experience we are going to give you. So let's move on to the lecture, and if you want to join Unacademy, just make sure you use the code Ankit ESE to get my guidance as well as to get 10% over and above whatever Unacademy offers you. So now let's move on to the lecture, dear friends, and let's see what we have in store for you.
Hi guys, in this lecture I will be discussing another application of op-amp with you all, and that application is known by the name of active filter. Now this term filter you might have come across at many places. What is filters? They are the devices or circuits that pass only certain frequencies and block other frequencies. Now what is meant by this term pass certain frequency and block other frequency? Suppose I say that a filter can pass 50 Hz frequency but it will stop 100 Hz frequency. So if you apply a sinusoidal signal of frequency 50 Hz, it will be passed by the filter. That means it will flow from input to the output. But if you apply a sinusoidal signal of 100 Hz, then it will not be passed, or you can say it will not appear at the output. So that is the meaning of the term pass certain frequency and stop certain frequency. It means it will pass signals of certain frequency, whereas it will stop the signals of other frequency. So the frequencies that are passed, that range is called as passband, and frequencies that are stopped is called as stop band. So the range of frequencies which can be passed by the filter are called as passband, and which are stopped by the filter are called as stop band. Let us take an example. Suppose I give you a filter of center frequency 30 kHz and 3 dB bandwidth 6 kHz. That means the spectrum of the filter or the frequency response is centered at 30 kHz and the bandwidth is 6 kHz. That means it passes which frequencies? It passes the frequencies in the range 27 kHz to 33 kHz. That is 3 kHz below the center frequency and 3 kHz above the center frequency. So what I mean to say is, the response of the filter is like this. This is 30, this is 27, and this is 33. So that is the 6 kHz bandwidth. So if I give you a square wave of 10 kHz and I ask you about the output. Now square wave is not a sinusoidal wave, but it is periodic. Any periodic non-sinusoidal signal can be expressed as Fourier series. So when we write Fourier series of square wave, it is written like this: n equal to 135 up to infinity 4v by n pi sine n omega naught t. Now n is a odd number 135. In signals we say that odd harmonics exist. So which frequencies are existing? Omega naught is the fundamental, 10 kilohertz. Then the third harmonic, 30 kilohertz. Then the fifth harmonic, 50 kilohertz. Seventh, 70 kilohertz. And so on. But the filter can only pass the frequency in the range 27 to 33. So which frequency will be passed? That is 30 kilohertz. It lies in the range of 27 to 33. So the output will be only one component, and that component will be sinusoidal. All these components add up to make the square wave, but the filter is only passing one component in the input, that is 30 kilohertz. So the output waveform will be sinusoidal in nature. Now that is the basic definition or basic working of a filter. Now the question comes, what is this active filter? Active filter is basically a filter which is implemented using some active device such as BJT, op-amp. But if you are implementing a filter only using passive elements like R, L, C and so on, then it is called as a passive filter. So since we are studying op-amp, we will be understanding how we can use op-amp to generate a filter circuit, and in network analysis we talk about passive filter. There we only make use of the components like resistance, inductance and capacitance. Now the question that might come to mind is, when I can realize a filter just using R, L and C, what is the need to use op-amp? Why to increase the cost when we can simply generate using R, L and C? The answer to this is, in passive filter you cannot control the gain of the filter. That means the gain will always be less than 1. A passive system can never amplify the input signal. So the gain will always be less than 1. But in case of active filter, when you are using op-amp, you can control the gain of the amplifier and also you can control the frequency. So we can control gain as well as frequency in active filter, but this is not possible in passive filter. Okay. So we will be studying active filters in this lecture, and I'll mainly talk about 4 types of filter, that is low pass, high pass, band pass and band reject. Okay. These 4 kind of filter we will talk about. So first let us talk about the Butterworth low pass filter. Now what do you understand by low pass filter? A low pass filter basically passes frequencies that are less than a certain frequency. When we talk about an ideal low pass filter, how does the gain vary with frequency? This is your gain versus omega. So the gain is constant for frequencies less than a certain frequency omega h. That is an ideal low pass filter. So if you see ideal filter, what is the characteristic of ideal filter? That gain is not equal to 0 for omega less than omega h and gain equal to 0 for omega greater than omega h. So when gain is non-zero, this is called as your pass band, and where the gain is 0, it is called as your stop band. And you can see that there is a sharp cutoff between the pass band and the stop band. There is sharp cutoff. Now this filter is not practically realizable. We desire this kind of filter, but it is not practically realizable. Practical response is something like this. It gradually reduces and becomes 0. So that is the practical variation of gain versus omega. And how do we define the cutoff frequency? At omega equal to omega h, the gain is, suppose this is A, it will be A by root 2. So what is omega h called as? It is called as cutoff frequency. I told in BJT also, it is called as 3 dB frequency, or it is called as half power frequency. Why half power? Because if signal becomes 1 by root 2, then power is always proportional to the square of amplitude. If power is proportional to the square of amplitude, then the power will become half. Okay, that is called as the half power frequency. Now most of the times, if we have, it is talking about first order. In network analysis, we say that order of a system is equal to number of energy storage elements. That means in first order filter, I'll only have one energy storage element, which in our case is a capacitor. In this case, that element is a capacitor. Now most of the times what we do is, we draw Bode plot for a filter. Now if the transfer function of the filter is something like this, then what is the corner frequency of this filter? It is 1 upon T. How does the Bode plot look like? The Bode plot looks something like this. This is the corner frequency 1 by T. What is the slope of this line? The slope is minus 20 n dB per decade. Okay, minus 20 n dB per decade, where n is the order of the pole. This is also called as frequency roll-off factor, which will in this case be minus 20 n dB per decade. Now in this case, the filter is first order. First order system only has one pole. If it only has one pole, n is equal to 1. So frequency roll-off factor will become minus 20 dB per decade. Now why I am telling you about the slope or the frequency roll-off factor? Think like this. If you increase the value of n, then the slope will become high. As you go on increasing the slope, this line will be more tilted. And if the line is more tilted, it is approaching the ideal characteristic of the filter. So by increasing the order of the filter, we can increase the slope of the line and we can go to the ideal filter, or we can go as close to the ideal filter as possible. Okay, so that is the basic idea behind increasing the order of the filter. But when you want to increase the order, you have to use more energy storage element. That means the design of the filter itself will become very complicated if we increase the order of the filter. But what is the benefit? That we are approaching the ideal filter. Okay, so are you getting my point? So in our course, we will only talk about the first order filter, that is shown in the figure. So let us analyze this. In filters, our approach will be to find the transfer function. Okay, I'll always try and find the transfer function of the filter. Now as you can see, this system has negative feedback. If it has negative feedback, I can make use of virtual ground. And also if you see, you are applying input at the non-inverting terminal. It is nothing but a non-inverting amplifier. We know that there is no current at the input of the op-amp, so R and C will be in series. Can you find out V1 for me? V1 will be V in, I am applying potential division, 1 by SC over R plus 1 by SC. That is V in over 1 plus SC R. That is the value of V1. Now since it is a non-inverting amplifier, we can say that V0 is V1 into the gain of non-inverting amplifier 1 plus RF by R1. So you can say V0 is V in 1 plus RF by R1 over 1 plus SCR. So the transfer function is nothing but the ratio of the output to the input voltage 1 plus RF by R1 divided by 1 plus SCR. Now if you convert it to j omega, you just have to replace S by j omega. So what is the magnitude of this gain? How do you find magnitude of a complex number a plus iota b? Under root a square plus b square. So as you can see there, you can say as omega increases, mod of tj omega decreases. Omega is in denominator, right? So as you increase the frequency, the gain of your amplifier will reduce. So at omega equal to 0, what is the gain? 1 plus RF by R1. Let me call it as feedback gain AF. What about omega tending to infinity? If omega tends to infinity, the denominator becomes infinite. The magnitude is 0. So you can say that the voltage gain of this filter, mod of voltage gain, is AF by under root 1 plus omega square C square R square. Now if you plot this gain against frequency, so at omega equal to 0, what is the value of gain? It is AF, and then it reduces and it becomes 0. Now what we need is the 3 dB frequency, that is the frequency at which gain becomes maximum gain by root 2, or you can say DC gain by root 2. DC means when the frequency is 0, the gain is called as DC gain. So this is called as your DC gain. So if you want it to become AF by root 2, in that case if you square both the sides, you will say it is equal to 2, or you can say omega h is 1 by RC, or FH is 1 by 2 pi RC. Now if you remember, when we were determining the cutoff frequency in BJT and MOSFET, I told you about the same concept, that the cutoff frequency is simply 1 by 2 pi RC. Okay. Now what you have to do is, once you have the gain, now the transfer function in j omega was 1 plus RF by R1, which is AF, by 1 plus j omega CR. If I ask you about the angle of this transfer function, the angle will be minus tan inverse omega CR. It is always less than 0. That is called as phase lag. So in the language of control system, it is also called as your lag compensator. Okay. So this is your lag compensator because it is providing a phase shift of less than 0 or a negative phase shift. Okay, and what we have seen, the 3 dB or the cutoff frequency is 1 by RC, or FH is 1 by 2 pi RC. This lag compensator you will come across more in case of your control system. Now what is the direct method? If I wanted to find the gain directly, what I'll do? See, capacitor has a reactance 1 by omega C. So at omega equal to 0, Xc is infinite. Reactance infinity means open. At omega tending to infinity, Xc tends to 0. Reactance 0 means short. So if you open circuit the capacitor, Vin directly becomes V1. When capacitor is open, Vin is V1. So Vout is Vin into gain of non-inverting amplifier 1 plus Rf by R1. And when capacitor is short, if you short circuit this capacitor, V1 is 0. So output voltage is also 0. Okay. So that way you can directly determine at 0 and infinite frequency what is the output voltage, and if the output voltage at omega equal to 0, what we are getting? Vout is Vin 1 plus Rf by R1. Omega tending to infinity, what we are getting? V naught equal to 0. So if the output voltage is high at low frequencies, then it is working as a low pass filter. That is, directly you can determine the nature of the filter by checking the output at 0 frequency and at infinite frequency. And this approach will very much help you during the examination, because there you might not have the time to always derive the transfer function. Now the question comes, practically how do we design a filter? So first of all, in filter what we need is cutoff frequency. Cutoff frequency should always be specified when you want to design a filter. Then you choose a value of capacitor C less than equal to 1 microfarad. That is your choice. Then since cutoff frequency is 1 by 2 pi RC, you can find out the value of R. And since the feedback gain is 1 plus Rf by R1, based on gain, you can choose the value of Rf and R1. So based on the gain that is specified to you, what gain you desire, you can keep the value of Rf and R1. So you need two parameters when you are designing. One is the gain and the second parameter is your cutoff frequency. Moving to the second filter, first order Butterworth high pass filter. So what I have done, I have exchanged the positions of C and R. Again there is only one energy storage element, one energy storage element, which means the filter is only first order. Okay, and I told you why do we want to go for higher order filters? In order to increase the frequency roll-off factor and approach the ideal characteristics of the filter. That is the main motivation behind going for higher order filter, but we are only talking about first order. Now again the input current to op amp is 0 ampere. So C and R are in series. How you will write V1? Vin, again I will apply potential division, R over R plus 1 by SC. This all of you must know that capacitor is represented by 1 upon SC. So Vin SCR over 1 plus SCR. So what is the transfer function? Sorry, this is Vin, this is only V1. Now this is simply a non-inverting amplifier. Why it is a non-inverting amplifier? Because we are applying the input at the positive terminal or the non-inverting terminal of op-amp. In that case, V0 is V1 1 plus RF over R1. That means V0 is Vin 1 plus RF by R1 into SCR over 1 plus SCR. So if you want to find out the transfer function V0 over Vin, it is 1 plus RF by R1 into SCR over 1 plus SCR. That is the gain of the filter is 1 plus RF by R1. I will write as AF into SCR over 1 plus SCR. Now if you calculate this gain in frequency domain, you will replace S by j omega. So it will become j omega CR by 1 plus j omega CR. Okay. What about the magnitude of the gain? If you calculate the magnitude, it is AF into omega CR, and what is the denominator? Under root A plus iota B magnitude is under root A square plus B square. Okay. That is the gain of the amplifier. Now what we want is at omega equal to 0, what is the magnitude of gain? Numerator becomes 0, so the magnitude of gain is 0. Let me write down the gain again for you. AF into omega CR by under root 1 plus omega CR square. At omega tending to infinity, what is the magnitude of gain? It is AF. Okay. Because at infinity, numerator and denominator will get cancelled. So magnitude of gain will become AF. Now we know at the cutoff frequency, here I am writing as omega L, as I told you in BJT. At cutoff frequency, the magnitude of gain should become AF by root 2. So AF by root 2 will be equal to AF. Now if you take omega CR in the denominator, 1 plus 1 by omega L CR square. If you square both the sides, you will say 2 equal to 1 plus 1 by omega L CR whole square. That means omega L must be 1 by CR, or FL must be 1 by 2 pi RC or CR. That is the cutoff frequency. Now when you draw the magnitude response means a graph between the gain and frequency of the filter, you will see that it is something like this. This gain is your AF, and the point where the gain is AF by root 2, this frequency is called as your FL or omega L. Okay. So it is working as a high pass filter. It is passing high frequencies and it is stopping low frequency. Okay. Now, just now we saw that the transfer function was this, gain was this. If you want to write the angle of this, the angle of numerator is 90 and angle of denominator is tan inverse omega CR. So now if you see that tan inverse is always less than 90. So 90 minus a value less than 90 will always be positive, or you can say lead. So it can act as lead compensator. Okay. So high pass filter always acts as a lead compensator and a low pass filter acts as a lag compensator. Is this point clear to you? Now, one thing that we need to understand is how will we design this high pass filter. Again, just like the previous case, the first thing that you need to understand or know is the cutoff frequency. So cutoff frequency will be given. Then what will we do? We will choose a value of capacitance less than 1 microfarad. Okay. Then based on cutoff frequency, we will determine the value of R, because FL is 1 by 2 pi RC, and based on the gain we will find out RF and R1. So the steps will be exactly same as the previous case, but it is a high pass filter, not a low pass filter. Okay. So if I write down the step, I'll say FL must be specified. Then the second thing, FL is 1 by 2 pi RC. Choose C less than equal to 1 microfarad and calculate R. Then select RF and R1 based on pass band gain AF. Okay. So that is how we will design a high pass filter. Moving to the next filter. The next filter is called as a active band pass filter. Now band pass filter is nothing but a filter that passes the frequencies between the two cutoff frequency, that is above a certain frequency and below a certain frequency, that is called as a band pass type of filter. So how do we show the response of a band pass filter? The response of a band pass filter is something like this. So it passes the frequencies between the two frequencies FL and FH. Earlier we were either passing the frequencies above a certain frequency or below a certain, but it has two limitations. FL is called as a lower cutoff frequency and FH is called as upper cutoff frequency. These are the two cutoff frequency. Now what is the simplest method of designing a band pass filter? Is first we take a high pass filter, then we connect an amplifier, and then we take a low pass filter. So what happens? High pass filter will pass frequencies above a certain limit. What limit? FL. Amplifier will only amplify this, nothing more. So spectrum will remain same, only gain will increase. But low pass filter will cut the frequencies above a certain frequency. Which frequency? FH. But for that to happen, what is the necessary condition? Necessary condition is that the cutoff frequency of low pass filter, which is FH, must be greater than FL. You need to design a low pass filter such that the cutoff frequency of low pass filter should be more than the cutoff frequency of high pass filter. Okay. So we are cascading three devices: low pass filter, high pass filter and a amplifier, but we must make sure that the cutoff frequency of low pass filter is more than high pass. See this figure? The first stage is a high pass filter stage. Capacitor is at the input, then resistor. What is the cutoff frequency FL? 1 by 2 pi R1 C1. The second stage is a non-inverting the second stage is a inverting amplifier. Input is connected at the inverting terminal. Okay. 1 minute, I think this diagram is incorrect because we need to use negative feedback. So this terminal should be positive and this should be negative. We are using negative feedback. Okay. So it is a non-inverting amplifier. Then we have low pass filter. First resistor, then capacitor. What is the cutoff frequency? 1 by 2 pi R2 C2. So you have to choose R1 C1 and R2 C2 such that FH must be greater than FL. Okay, that you need to take care. Another implementation of band pass filter I have shown in this figure. It is similar to what we studied in a differentiator. If you remember the linear application of op-amp, the closed loop application, there I modified the circuit of differentiator and the circuit was exactly same as I have shown you in this figure. So as you can see, there is negative feedback. So if there is negative feedback, what we can do? We can apply the concept of virtual ground. Also, if you observe that input is connected to negative terminal, so it is nothing but the case of inverting amplifier. And what is the gain of inverting amplifier? Minus ZF by Z1. ZF is the impedance in the feedback, Z1 is the input impedance. So what is the feedback impedance? That is C2 in parallel with R2. R2 parallel 1 by SC2. So R2 by 1 plus SC2 R2. What about Z1? R1 plus 1 by SC1. That is 1 plus SC1 R1 by SC1. Now if you calculate the gain minus ZF by Z1, it will become minus SC1 R2 by 1 plus SC1 R1 plus 1 plus SC2 R2. Okay, that is the gain. Now if you see this gain can be broken into two parts. Minus R2 by 1 plus SC2 R2. It is similar to a low pass filter. And SC1 by 1 plus SC1 R1. This function is similar to a high pass filter. But you just have to make sure that the cutoff frequency of low pass filter is greater than cutoff frequency of high pass filter. Then only this circuit can work as a band pass filter. So you can also remember that the practical circuit of differentiator will act as a band pass filter. The design of band pass filter is identical to the differentiator. Okay. And if you want to check the functionality, if you want to understand how it is working as a band pass filter, for that you have to do two things. First, you have to calculate gain as a function of j omega. Okay. So I have just replaced S by j omega. Now, if you calculate this magnitude of this gain, one plus omega square C1 square R1 square 1 plus omega square C2 square R2 square. Now at omega equal to 0, the gain is 0. At omega tends to infinity again, the gain is 0. Why I am saying at infinity it is 0? At 0 it is obvious, the numerator will become 0. But in the denominator, omega has a power 2. In the numerator, omega has the power 1. So at high frequency, denominator will dominate and gain will become 0. If the gain is 0 on both the sides, it can only be like this. So it can only be a band pass filter. which has low gain at both the sides. Okay, so that is how we can directly say that it is working as a band pass filter. Now, how you will design this filter? First of all, what we need to know? We need to know the cutoff frequency, but there will be two cutoff frequency here, FH and FL. Then we will choose the value of C1 and C2. Now we will assume two capacitors C1 and C2, both less than 1 microfarad. And we will calculate R1 and R2 using the cutoff frequency. FH and FL we will make use to find the value of resistance R1 and R2. And if you want to modify the gain, you can connect an inverting amplifier in front of it like this. If you want to modify the gain, you can go like this. Basically cascade an inverting amplifier, due to which this minus sign will also be cancelled, and you can control the gain by changing the values of RF and R. So if you want to control the gain, you have to introduce an additional inverting amplifier at the output of the band pass filter. The next filter is called as your band stop filter. Band stop filter means it stops a certain range of frequencies and passes the other frequencies. So how does the response look like? It looks like this. FL, FH. So it is stopping the frequencies between FL and FH. This is your stop band. And rest of the frequencies are passed. So rest of the frequency range is pass band. Okay. Now, how do we design this filter? Earlier we were cascading low pass and high pass filter, but this time they are connected in parallel. Okay. So the same input is applied to a high pass filter and a low pass filter, and they are connected in cascade. Okay. Then they are both passed to a summing amplifier, which we studied in the closed loop configuration. This is your summing amplifier. Now see, how will the characteristic of a low pass filter look like? It will look like this. Okay. So let me change the name FH and FL. It will be up to FH. How will the characteristic of high pass filter look like? It will be FL. Okay. Now when both these responses are added, we will get this value. But here we have to make sure this FH must be less than FL. That is, the cutoff frequency of low pass filter must be less than the cutoff frequency of high pass filter. That we always have to make sure. So see this circuit. What I have done? First I have connected a low pass filter. This one. This is a high pass filter. Then we have connected a summing amplifier which has two inputs. One is the output of a low pass filter and other is the output of a high pass filter. So that is how we design a band stop type of filter. Now a special case of band stop type of filter or band reject filter is called as notch filter. So we are deriving notch filter just from the band reject filter. In notch filter, what happens is that stop band is narrow, so filter stops only one frequency. it does not stop a range of frequencies, but it will only stop a single frequency. That is why the frequency response of a band stop filter looks like this. Okay. That is the response of a notch filter. It is stopping only a narrow region of the response. It is not stopping other frequency. Now the question comes to mind is, why do we need a notch filter? Now we study one term in power electronics that we don't study in analog. It is called as total harmonic distortion. Now what is this total harmonic distortion? When we want any waveform to be sinusoidal, but it contains harmonics, then the shape of the waveform is distorted, and that distortion is represented by ratio of harmonic RMS to the fundamental RMS. Now harmonic RMS is RMS value of all component except fundamental. That means you want to know the value of all the harmonics except fundamental. So you want to stop the fundamental frequency, and if we want to stop a single frequency, then what happens? Then we have to use the notch filter. So in any question, both the things cannot be given, like notch filter and band reject filter. Only one thing can be given, because notch filter is a special case of band reject filter. Okay. So where we will use notch filter? When we want to find total harmonic distortion, because we want to stop the fundamental frequency. Now this is the certain design of a notch filter that is given to us. It uses a voltage divider network to form the feedback using R3 and R4. And the notch frequency, this is the notch frequency Fn, in this case is always 1 by 4 pi Rc. This formula you can remember for this circuit. That is the frequency which this filter will stop, and it will have a very narrow band of stop band, so it will be called as a notch filter. So if I summarize what we have covered, I have told you about different types of filter, and how do you judge that kind of filter? We have to see the magnitude at two frequencies, mainly 0 and infinity. So when we talk about low pass filter, at 0 the gain is high, at infinity the gain is low, because it is like this. Then what about high pass filter? At 0 the gain is low, but at infinity the gain is high. So it is like this. What about band pass filter? The gain is low on both the sides. So it is like this. You don't have to memorize any circuit. What about band reject filter? The gain is high on both the sides. So it is like this. But there is one more filter. Band reject filter also has a category, notch filter. But notch filter is just a type of band reject filter with a very narrow band. One more filter that I haven't told you about is the all pass filter. All pass filter also has high gain on both the sides, but the special thing is that the gain is constant. So when you calculate magnitude of gain, if it is not a function of frequency, then it will be a all pass filter. Okay. So an all pass filter, what category it has? That it will pass all the frequencies, it will not stop any frequency, and that will mean that the gain of the amplifier or filter is independent of frequency. Now suppose I give you a transfer function like this, 1 minus SCR over 1 plus SCR. So what you will do? You will convert it to j omega and you will write 1 minus j omega CR over 1 plus j omega CR. Then you will calculate the magnitude, under root 1 plus omega CR whole square by under root 1 plus omega CR whole square. That is 1. It is constant. So it is an example of all pass filter. If you ever want to directly recognize the all pass filter, for an all pass filter, when we draw pole 0 plot, the poles and zeros are symmetric about imaginary axis like this. So what we say, poles and zeros are mirror image of each other about imaginary axis. Okay. Now if you want to differentiate between band reject filter and all pass filter, at 0 and infinity the gain is high for both. Check an intermediate frequency like 10 radian per second, 20 radian per second, and if you get the same value of gain, then it is a all pass filter. If you get a different value, then it is a band reject filter. Because for an all pass filter, the gain will be constant at all the frequencies. So if you are confused between band reject filter and all pass filter, always check an intermediate frequency between 0 and infinity. That will give you a fair idea. Okay. So that is all about the active filters. In the next video, I will solve some problems based on filters. Thank you.
For 12 months, the pricing is 3250, but if you apply the code Ankit ESE, it becomes 27225. For 18 months, it will be 34650, and for 24 months, 39600. Believe me, my dear friend, this is the most affordable pricing, and the longer duration subscriptions are more cost effective as compared to shorter duration. Like here, it will cost you 1650 per month. Okay, this will be 2000 per month approx. This will be around 2250 per month. Then if you go for Iconic for 12 months, it is 5250 with code Ankit ESE, it becomes 45225, and 2 year subscription becomes 66600. So the choice is your, but take a longer duration subscription for more cost effective solution and to give GATE and ESE at least 2 times, so that if you once crack GATE, in the next attempt you can even get ESE. And other than that, my friends, you can download the Unacademy learning app right now, because there we provide live classes for free, test series and live quizzes for free. And once you download it, make sure that you follow this profile. This is my profile, so that whenever I come live, you will get the notification. And this is the Telegram channel for our team. Here you will find all the lecture links, all the lecture files, and all the links for the special classes. Other than that, my friend, my personal Telegram channel also you can join, t.me/GateAIR1. Here you can get in touch with me and we can take this journey together. Okay. Other than that, we have other YouTube channels like Mechanical, Civil and Telugu, JEE channel, Computer Science, Gate Question and Electrical Junction, Pathshala and GS Terminal. Electrical Junction contains short videos of great concepts. Pathshala provides you animated content. JEE preparation can be done through these 2 channels, Unacademy SSC JEE and GS Terminal. And you can refer the other channels to the other friends in respective branches, so that they can also be benefited. At last, I would like to say, please share, like and subscribe to this channel. Subscribe to this channel, and not only subscribe, press the bell icon so that you get notified whenever a new video comes. And share these videos among all your college group, among all your friends, so that we can create the first ever revolution of free education in field of GATE and ESE. Thank you to everybody for dedicating time to watching this video. Please move on to the next one as well and take the benefit of all the free content that we are providing. And in case you have completed the series, do make sure you watch the other subjects available on this channel. Thank you.